Hello everyone, my name is Mashahad Al-Amr. I'm a third-year PhD student in Forensic Linguistics, supervised by Dr. Alison May from the School of English and Professor Eric Atwell from School of Computing at University of Leeds. I'm from Riyadh, Saudi Arabia, where I work as a lecturer at the Department of English Language and Literature, College of Arts at King Saud University. It is a pleasure to present at ICON2020, and if you have any inquiries, I'll be happy to answer them via email. So my presentation today is about WEKA and forensic authorship analysis, a corpus-based approach of Saudi authors. The field of authorship analysis aims to identify or attribute one or more disputed texts to a single or multiple authors, either from a closed set or an open one. In a forensic context, the text can be forensic evidence, legal document, among other forms. Recent trends in forensic authorship analysis incorporate artificial intelligence tools to ensure reliable results that are free of cognitive biases. First, I will talk about studies in authorship identification. There's a substantial amount of studies to discover the possibilities of using machine learning tools using a range of data sizes. Many studies confirm that accurate authorship identification results can be achieved using small-sized data. Also, research explored the performance of classifiers. Several studies found that linear support vector machine demonstrates accurate classifying results when it comes to nominal data compared to other classifiers, while decision tree J48 and multinomial naive Bayes perform more accurately with numeric data. In terms of n-grams, charactergrams proved to perform well in short text such as WhatsApp and Twitter messages, but with some limitations to identify authors' texts without cross-examination. As for wordgrams, some studies conclude that unigrams, even in the shape of an emoticon, can show good results in identifying authorship. Bigrams proved to be successful in identifying authorship in literary texts. And when it comes to authorship identification in Saudi Arabia, a body of literature has been published in the field that focuses on computational approaches, which leaves out the linguistic and stylistic approaches. Another issue is that the authorship identification studies in Saudi do not address the forensic context. Moreover, social media platforms such as Twitter are heavily populated by users who sometimes abuse such mediums. Saudis are responsible for 30% of all tweets posted, as per a report in 2017. At the same time, there are efforts in Saudi Arabia to fight cybercrime and issue regulations that incriminate hate speech and offensive language published online. This calls for a need to contribute to the field of forensic linguistics in general and forensic authorship analysis in Arabic in particular. WEKA is a collection of machine learning algorithms that perform data mining tasks. Its tools can achieve pre-processing, classification, and clustering of the data, and is capable of developing new machine learning schemes. So, WEKA seems to be ideal to pre-process, classify, and even create machine learning schemes for identifying authorship, which is what the study aims to explore using the Najdi Arabic dialect. So the research question this presentation aims to answer is, first, what is the size of data required for WEKA to identify authorship accurately? Second is, which classifier can accurately identify authorship using the NAS corpus? And lastly, which parameter is most accurate to identify authorship using the NAS corpus? So, looking at the methodology of the research, the data collected for the study are the author's posts published on Twitter. To ensure authorship, all original tweets and replies were included in the corpus, while retweets were eliminated. The corpus was compiled using DataMiner, a Google Chrome extension that identifies Arabic script. The time period of the data collection started back in March 1st, 2018 and ended in September 30th, 2019 for a period of 18 months. The data was produced as Excel sheets, which were converted into .csv file format. The sample of the study are 6 males and 7 females, all originated from the central region of Najd and current residents of Riyadh, the capital of Saudi Arabia. In terms of ethical considerations, all authors' accounts are public and verified, thereby the tweets they post are public data. Lastly, all authors run the Twitter accounts personally, which ensures authorship. So this is the breakdown of the Najdi Arabic specialized corpus of tweets, NAST, and as you can see, there are the names of the authors, the number of tweets, which adds up to a total of 58,005 tweets. The words are in total 748,348 words. As for the profiles of the authors, mostly are influencers because that seems to be ensures us that there are prolific users of Twitter, which translates well into the size of the data. To explore the NAST using WEKA, we converted the .csv files into ARF file format. And in order to train WEKA, we reassembled the corpus into 13 separate ARF files per author and 2 data training sets. The first is an unbalanced dataset, TS1, which includes the full corpus. As for the previous slide shows, the subcorpora of some authors are substantially larger in size compared to others, so we created a balanced dataset, TS2, which includes equal number of tweets per author. Both datasets include 80% of the author's data and a header describing the types of linguistic attributes being examined. The remaining 20% of the author's subcorpora was combined into one ARF file for testing. So the table here shows the numbers of tweets per dataset. The TS1 contains 44,192 tweets, while the balanced dataset includes 25,247 tweets. So to explore the classifiers and see which one performs best, the first step was to examine different classifiers. We ran a test using 7 classifiers. First, linear SVM, multinomial naive Bayes, decision tree J48, KNN depth 3 and KNN depth 5, random forest estimator 5 and random forest estimator 15. The table shows the performance of all the different classifiers in 3 categories, the first being unigrams, bigrams, and trigrams. The results of the first test shows that linear SVM scores the highest accuracy rate, as was predicted by previous studies. Therefore, it was implemented to be carried out for the next stage. For the parameters, we ran 3 tests to explore a range of parameters that can ensure the highest accuracy rates. In the first stage, the minimum value is words that appear once and words that appear 60% of the data files. The second parameter eliminates words that appear twice or less and words that occur in 80% of the data files. And the last one test eliminates words that appear once and words that appear in 95% of the data files. In the first parameter test, both data sets scored the highest accuracy rates. These scores were most accurate across the 3 n-gram categories. So it's basically a range of 0.59, 0.6 respectively. The first dataset TS1 scored a consistent and better performance compared to the unbalanced dataset TS2 in the second parameter. The accuracy rates of the balanced data in the second parameter test were inconsistent. On the other hand, TS2 scored consistently higher results in the third parameter test compared to the unbalanced set TS1. Nonetheless, both training datasets scored consistent results in unigrams, bigrams, and trigrams. Also, it appears that the balanced dataset TS1 scores the highest overall results in unigrams, while the unbalanced dataset scores the highest overall results in bigrams. That being said, the optimum parameter is the first test using bigrams. So this leads us to the conclusion of future studies. The study aimed to explore WEKA and forensic authorship analysis research. To answer the first research question, the authors found that the unbalanced dataset performed better than the smaller balanced one. The large size of the data provides WEKA with training and recognizing the features more accurately. As for which classifier performs best, results show that linear SVM is the most accurate performance, which conforms to the studies of Fissat and Picardo et al. Lastly, the results show that bigrams can accurately identify authorship, which confirms the findings of Fagina and Hurst. There is a potential for future studies implementing different proportions for training and testing might yield higher, more accurate rates. Another possibility is exploring different types of data, maybe longer stretches of text instead of posts. That could lead to different results, maybe. Lastly, exploring maybe another language could also show the possibilities of using WEKA in classifying authorship. So thank you so much for your attention, and for feedback and inquiries, please email me.